So we are doing numericals on laws of motion, force. We have done one or two numericals yesterday. Today again we will take it up. The block A, B, C of masses 4, 2 and 1 kg respectively are in contact on a frictionless surface as shown in the figure. If a force of 14 Newton is applied on the 4 kg block, then the contact force between A and B. Okay, what we are studying is contact forces. In contact forces, we will study two types of examples. I tell you what is the meaning of contact force. If there are two objects and they are in contact with each other, I apply force on this is applying force on this, and ultimately there may be certain acceleration, there may not be. So there are different type of questions formed in it, like if I am applying 10 Newton here, then how much it is applying on it? It may not be 10 Newton. It may be less, more, anything like that. Simply, this is one way contact. This also we have seen in the examples of rail compartments. Engine apply force on the first compartment, then how much force is applied on the guard compartment which is in the last. So, no, it is not same. And that is what we are going to study, and that is sometimes asked. That is contact force. Similarly, the pulleys and the two weights which are hanging across the pulley, we apply force on one, how much is the force on the other? So these type of applications, numericals, are contact forces. We will do that one by one. Okay, so here is the contact force. This is 4 kg, 2 kg, 1 kg. They are in contact with each other, and now you read it. If force 14 Newton is applied on the 4 kg block, then what is the contact force between A and B? Where we are applying force on A, and what we want to find out, what is the contact force between A and B? We are applying force here. Okay? And what we want to find out, what is the force which is applied by A on B? That will be here. A to B. Okay. How to do it? So what is our principle? Why these forces should be different? And remember the answer. Things will be very clear. I am applying force on A. How many boxes I am pushing? A, B and C. A is applying force on B. How many boxes it is pushing? B and C only. But all the boxes are going with the same acceleration. Then I am pushing 3. A is pushing 2. B is pushing C by 1. Only one box. Should our forces be equal? No. Because we are getting same velocity, same acceleration, but I am doing it for 3, A is doing it for 2. So forces has to be different. This principle is clear to you, why it should be different? Right. Now, how to calculate it? For calculation, a very easy formula you have. Force is equal to mass into acceleration. And in that, please remember, acceleration of the complete system is 1. A, B, C, all are moving with the same acceleration. Okay? Other component force. When I push at A, how much mass I am pushing? 7. Okay, A is pushing B and C. How much mass? 3. Right? So you got the mass for my force, you got the mass for A force on B. Right? What do you need? Acceleration. And that is very easy thing. How much is the total force applied? You get it here, 14 Newton. Right? How much is the total mass? 7 kg. What should be the acceleration of the complete system? Yes, 2. This is acceleration of the complete system. Right? Now you got the A. How much force is applied by A on BC? How much weight it is putting? How much mass? 3 kg. What is the acceleration of the system? 2. So what should be the force?
6 Newton.
6 Newton. You got the answer. Okay. How much B is applying on C? C, mass is 1, acceleration is 2 Newton. Right? Okay. So, once again, how much I am applying?
14 Newton.
14. Out of this 14, how much A is applying on B?
6.
That is 6. What happens to rest 8? Answer is 8 is being used to accelerate A. How much is remaining? 6. 6 is transferred here. How much it is transferring here? 2. That means how much it is using?
4.
Yes. It is 2 kg with acceleration 2. How much is the required force? 2 into 2, 4. So this one is using 4 Newton. This is using 2 Newton. And this is using 8 Newton. Total, I have to apply 14 Newton. Is that clear?
Yes, sir.
This is how we make whenever there are contact forces. So please remember 2 steps. First, find out acceleration of the complete system. How you will find? Total force divided by total mass. Once you got it, that acceleration is attributed to all the parts. Now wherever you want it. Now suppose the train is going in this direction. I am changing it. The train is going in this direction and we are, yes, pushing it this with 14 Newton. Okay, now can you tell me what is the force applied by B on A? Pardon? 8. Very good. Because this force is used to push how much mass? 4 kg. And what is the acceleration? 2. So 8. B is putting A with 8. How much C is putting B? This is 2 plus 4, 6 multiplied by acceleration 2, 12. Got it? So this is how you will make all contact force questions. Okay, let's proceed further. Block A of mass M1 rests on the horizontal table. A light string connected to it pass over frictionless pulley at the edge of the table, and from its other end another block B of mass 2 is suspended. This is block A, this is block B. It is suspended from a frictionless pulley. Okay. A question further. The coefficient of kinetic friction is given to us, that is mu k. Okay. Now, when the block A is sliding on the table, what is the tension in the string? This we are supposed to find out. So, where is the question line? Question line is here. The tension in the string is this. Right? Tension is what? Force. And that force is pushing it. Okay, come here. What we are supposed to find out? Tension. Here I want to introduce to you something which is known as free body diagram. The technique of free body diagram. Once you learn that free body diagram, things will be very easy for you to solve numericals of forces. Okay, it will take 2 minutes. This is a system. In this system there are many bodies. This is one body, the string is one body, that is one body, table is one body. There are so many bodies. Force is being applied by this string. Force is applied on this by mg. Then this string is pushing it here, force, and this string is pushing it in this direction. That is also a force. The friction is applied on this at that time. So you find there is a force of friction, there is a force of tension, there is a force of gravity, and all these forces are working in this system. How do we make our calculation for acceleration? That becomes a problem. So to solve this problem, we have a very good system in physics. What we do, at any point of contact, we choose one body, one point, one body, and we mark it, and then we forget everything else, apply our formula on that particular body. So I will do it here. Where is, that is K, this. M1, M2, which is M1, the one which is resting on. And what is M2? Yeah. This is M1 and this is M2. Okay? Right. Now, what I request you to consider only this and make this thing free from the complete system. This system may be a very large system, so many things here, there, everywhere. But we mark only one thing, one body, only one body, and free it from the system. When you free it from the system, what do you get? I make it here. What you get is a box, a force acting upward, and a force acting downward. That's all. Right?
Yes, sir.
Now, see here. What is the mass of this box? How much force is acting up? Tension. Okay? Tension. Now, we know the principle that tension in one string is same value at every point. So, if I say T1 is there, T2 is there, then T1 must be equal to T2. We say it is T. Correct. Okay. So, this T is acting upward, so I write there T. What is acting downward? Mg. So, here it is Mg. Acting downward. Now, there is a body of mass M2. This is one force, that is the other force acting on it. So, what should be the net force? Net force is the difference of the two. Okay. And in which direction the body will go? Whichever is larger. Okay. So, in this case, the body is coming down. In this system, where the body is going, is just going up or down? It is going down. If it is going down, then which is larger? M2G is larger than T. So how much is the net force? M2G minus T. This is the net force. If this is net force, then what will be the acceleration? Acceleration is, again, force is mass into acceleration. If acceleration is A, then how much is net force equal to? Mass into acceleration, M2A. So, with this I get a formula. That formula says mg minus t, that force, is equal to mass into acceleration with which it is coming down. It is coming down with acceleration A, and this is the formula I get.
Yes, sir.
Now in this formula, I am not confused by how much is M1, how much is friction. What the other things are doing in the world, not concerned. What we have done, we have taken one body and make it free from the system. This is known as free body diagram. So initially we make it separate. Later we will not make it separate. We will do the calculation. We will observe only one body and will not see the other body. Okay. Now once we have done it for this, please do it for that also. How much is the force acting on it? T. In this. How much is the force acting? T. Right? Any force backward? Friction. Is it given in the question?
Yes, sir.
What is given? There is a, yes, you have seen this. Mu. How much is the force of friction? Answer: mu into normal reaction. That is mass. So what should be the force? Mu into M1. How much should be the force? M1. And in which direction will it work? Backward. Here it will work in backward direction, because what is the intention of motion? Forward. If the motion is forward, it is moving in forward direction, the friction will act in backward direction. Now make a free body here. If you make a free body this, what is the force in rightward? T1. What is the force backward? Mu into M1. What should be the net force? Which is larger? T1 is larger because it is moving in this direction. Okay, if T1 is larger, then what is the net force? T minus mu into M1 into G. Right? So this is the force which is acting backward, and this is the net force. This net force is equal to mass into acceleration. Mass into acceleration, M1 is mass and this is acceleration. This is how you make free body diagram formulas. Now once you have made it, in these questions, in these all force questions, there is a technique you must remember. The two quantities, one is tension and one is reaction. Sometimes we don't have their values. If we don't have their values, we can always cancel out them if you want to. So this is a question. What is the sign of T? Minus. What is the sign of T? Yes. If you add the two equations, cancel. What unknown quantity will remain there? A. You will get the acceleration of the body. Right? Let's do that. Here. You get value of A. Divide the two. When you divide the two, you get the value of A. Right. Now when you get the value of A, put it in the equation and you will get the value of T. It is a simple mathematics. Two equations for two unknown. You can do that. So other unknown T, you got it this way. And when you got it this way, M1, M2, 1 plus mu k G upon M1 plus M2. This. So you go back to the question and find where it is. It is at point C. Right? You got the answer. So this is the method, and this you are going to use, free body diagram, and this free body diagram will act in each and every numerical of force. Right. So this is how it is done. And should we go to the next question? Okay. This figure shows two blocks in contact sliding down an inclined surface of inclination 30 degree. The friction coefficient between the block of masses 2 kg and incline mu1 is this much, and between block of mass 4 kg and the incline is mu2, which is equal to 0.3. Okay, find the acceleration of 2 kg block. Find the acceleration of 2 kg block. There are two blocks here which are trying to slide down. There are two possibilities. The thing is given to us, they have got different friction, different coefficient of friction. Quite possible that this will slide faster and this will be slow.
Yes, sir.
In that case, there will be separation between the two. Okay? But in case both are moving with the same velocity, same acceleration, no gap. But in case this is faster, this is slower, then what will happen? They will remain in contact and they will keep moving. So there are two possibilities, that they are moving together or they are moving separate. How can you find out whether they are moving together or they are moving separate? Acceleration. Right? So first we check that. Since mu1 is greater than mu2, acceleration of 2 kg block will be more. Right? Which friction is larger in the question? mu1 0.2, mu2 0.3. And mu2 belong to what? The friction coefficient between block of mass 2, 4 kg. So what is the friction for 4 kg? 0.3. This has got 0.3. This has got 0.2. Where friction is more? 0.3. So what will happen? Will it go faster or slow? Slow. 0.3 friction. Friction applies brake. right? So here it is 0.3, here it is 0.2. If I leave it free, how much is the friction? 0.3. It will go slow. If I leave it free, friction is only 0.2. It will go fast, but it is on the way. So what will happen? They will come together. And it has to go by speed of this. Together they will go with the same speed. This is the first conclusion we have to make, and here it is. Since mu1 is less than mu2, acceleration of 2 kg block down the plane will be more than acceleration of this, if allowed to move separately. But we don't allow. But as the 2 kg block is behind 4 kg block, both of them will move with same acceleration. Together? Okay, this point is clear. Now we have to find out the force. How much should be the force of the system? So force of the system, how do we find it? If this is mg, then we know reaction is mg cos theta, and the force which is bringing it down is mg sin theta. This should be always remembered by us. How much force bringing along the incline? Mg sin theta. And how much is the reaction? Mg cos theta. Remember that? This should always be there, that with the incline it is always mg sin theta. This is gravitational force which is bringing it down. Okay, if it is bringing it down in this way, then how much is the m? M is 4 plus 2. This is g and this is sin 30. Mg sin 30, this is the force bringing it down. 30 Newton. Right. Then after that, who is resisting it? Friction. So that is the force up the plane. Mu, the first one, mu, the second one. How this expression has come? Do you remember? What is the formula for frictional force? Please give your attention here. Mu into R. What is R? Reaction. And in this question here, what is R? Yes, R is equal to, yes, this is action downward and this is reaction upward. Both are equal to each other. Therefore, the value of reaction is mg cos. Yes. How much is theta? 30. So cos theta is known to us. Mg is also known to us. The only thing you have to take care is mu into R has to be done separately for both the blocks. Why, you know? Why? Because the mu is different for both. So we do them separately this way. Mu1 for one block, mu2 for one block. Mu into mg into cos. Mu into mg into cos for 2 kg, for 4 kg. Right? So this is what? Resisting force. Force of friction. And we calculated it. It comes to be 13.76 Newton. So the force acting downward we have calculated. Force acting upward we have calculated. And you can always find out the net force. Net force. So net force down the plane. This minus, this is the net force. And once you know the net force, then force upon mass. Force upon mass. What does it give? Acceleration of the system. This is how it is to be done. Right? So it's very easy and clear one. Okay. So once you have done it, let's go to the next question. Two blocks of mass 5 kg and 10 kg are connected by a string passing over pulley as shown in the diagram. This. There are two masses 5 kg and 10 kg connected by a string passing over pulley. Another string connects the center of the pulley to the floor and pass over another pulley A. What is this? Okay. An upward force F is applied at the center of the pulley Both the pulleys are massless. Find acceleration of block M and M if F is equal to 100 Newton. This is a pulley, 5 kg, 10 kg. The tension in the string is how much? T. Now this is connected with the other pulley. See how much is the connection tension? T naught. This T naught, we have another pulley here connected with this T naught, and we are applying a force here, right? So this is how the pulleys are connected and what we are supposed to find out. Okay, see, what I understand is that this pulley is connected with the string and that string passed through over another pulley, right? And we are applying a force F there. That pulley is separated here. T naught is coming from this direction and F we are applying here. Okay, what is the relation between T naught and T? The answer is here. What is the direction of tension at this point? That is downward here, and here it is this way. Both are working downward. If these two are working downward and pulley is here, then how much this should be equal to? T plus T, 2T. So we got one equation. What is that? 2T is equal to T naught. Same thing you apply here. This is T naught, this is T naught. So what should be F equal to? So you got the equation 2T naught is equal to F. Is it clear to you? This procedure, that at the center the ultimate force on the pulley is equal to sum of the two tensions, because this is also pulling it down, this is also pulling it down. So this one is equal to 2T. Is that clear? So we got those two equations, and let's move further. How much force and T, how they are related? Half, further half. That is 1/4. So 1/4 of the force is equal to tension. That point is clear to you? And how much is the force given to us? So F upon 4, F is 100. Then how much is T? 25. Here the tension is less than mg and mg, both. So it is not sufficient to lift the masses. Not sufficient to lift the masses, and there will be no motion. Right? But you understood how the equations are to be done. So what is the first thing? If we want to lift, if we want to move the mass, you see here, yes. If there is a mass here and this mass has to be lifted up, what is the condition for that? That the tension at this point, which is acting upward, this tension, this should be larger than the mass. If this is to be lifted box, then this tension should be larger than the mass. But what we have found, the tension is less than both the masses. That means what will happen? It is not able to lift any of the mass. Like I give you example, it's not a very difficult thing. We have a scale. You have seen a scale, Taraju? Right. And here, 2. You put 5 kg here, you put 10 kg here. This is 50 Newton, this is 100 Newton. How much total? 150 Newton. Now I apply force here to lift it. So I am applying 40. If I am applying 40, neither this will be lifted nor this will be lifted. My tension or the applied force is less. If I apply 70, the 50, one will rise. If I apply more than 150, then both will rise. Is it clear? So here what we have calculated, the tension here is less than this force as well as this force. So all the system will remain like that. and it will not move. So this gives us a lesson that tension has to be higher than the one mass. Then it will be able to lift that particular mass, and this situation we will use in other questions. Right. Okay. Now we change the value of force. I took it 100 from here. I tested with 100, no lift. Then I will test with 300, then I will test with. Understand? In which case it will be lifted, I want to know. So if if F we take as 100, how much T is coming to? 25, which is not sufficient. Right? So this is gone. If we take F, how much? 300. Then 300 upon 4 is 75. Then tension is less than mg, but more than mg. This you understand? There are two. Okay. It is less than 1, but more than 1. The m will remain stationary on the floor while the other one will lift. I gave you the same example. Okay. In third case, how much was the tension? In third case, it was 500. 500. If we apply the force of 500 up, then what is going to happen? See here. Yes. 500. Then tension 500 upon 4 is equal to 125, which is larger than 100 as well as larger than that 25. So what will happen? It will accelerate both upward. And how much will be the acceleration? T minus mg upon m, and then we can get this acceleration on the smaller part. That is 125 minus 50 upon 5, 15 meter per second is the acceleration of the lighter, which has got mass equal to 5. And the one which has got mass equal to 10, this is the tension 125 minus 100 upon 10. Could you get it? You see, this is mass 10, this is mass 5, both are being pulled by tension. Here is T naught for F, whatever it is there. When this T is equal to, this T should be more than 10 into G, that is 100 Newton, then this will be lifted up. When it is happening only in case 3. Case 3. How much is tension coming to?
125.
Is that clear to you? Okay. So 125 minus 100, that is the net force, divided by G will give the acceleration. Right? So same, we get the acceleration for this 15 meter per second, and this will have acceleration of 2.5 meter per second. Is it clear? Please revise it once again, then it will be clearer to you. And remember that example, we are increasing the force. 100, none of them is lifted. More than that, 300, one is lifted. And when we make it 500, then both are lifted. When both are lifted, then our calculation starts. How much is the calculation? Tension minus this force divided by mass, the acceleration. Tension divided by this force divided by mass give the acceleration of this. Right? So this is how we make it. This is slightly difficult. Would you like to do that? But you have done rotational motion, momentum. You can do it. This is again a very famous question, just like we have done the question of river and boat, the question of rain and umbrella. Similarly, this is known as ladder question. This is then in rotational motion we will see one very famous question, problem, that is yo-yo problem. Have you done yo-yo problem? You have seen yo-yo, what is that? That you play? Yeah. So that we will study when we go for rotational motion tomorrow or day after tomorrow. Okay. So this is ladder problem. See the question. A 4-meter long ladder. It has got some weight. It is rest with the upper end against a smooth wall and lower end on a rough surface. Where is the friction? Only on the floor, not with the wall. Okay. Between ground and the ladder. Okay. What should be the minimum coefficient of friction between ground and the ladder for it to be inclined at 60 degree with the horizontal without slipping? You see, if we have a ladder here and yes, it may slip. If I go here, there will be weight down and because of that it may slip. Who is holding it from slipping? Friction. So, if there is a force here which is pushing it in this direction, the friction in this direction should be sufficient to hold it. Right? And that friction is equal to how much? Mu into R. So, that mu we are being asked. How much should be the value of that mu here? If it is rough sufficiently, then it will hold, otherwise it will slip. We all know that. So that mu we are supposed to find out. Now there is a fixed procedure for that. The first thing is, you should be able to find action-reaction pairs, the force and reactions, because everywhere whenever you want to calculate friction, what you need? Mu into R. R is required. Okay. So we put the ladder here. Let us see the question again. 4-meter long ladder. You have the value of 4 meter here, which she has not written. Okay. This is 4 meter. This is 4 meter long. The next thing given is smooth wall, 2 ends, rough ground. What should be the minimum coefficient of friction between ground and the ladder for it to be inclined at 60 degree with the ground? We have made it 60 degree with the ground. Then this angle is automatically 30 degree, that we know. Okay, so this is how the ladder is. It has got certain weight W, and what we want, it should not slip. So now see the solution. In this figure, the ladder of weight W which act at center of gravity. 11:30. 60, 30. Now let us start it. Reactions N1 and N2. This is pushing the wall in this direction. What the wall will do? Third law, equal and opposite normal reaction. Why normal? Because it is normal to the wall. This is N1. This is one reaction. At this point, the ladder is pushing the ground downward, so reaction is upward. N2. These are two reactions. Which is any other force? Answer, weight of the ladder. Weight of the ladder, where does it work? At center of mass. This is center of mass and it is working. This is W. Now, very important principle. The two things you must remember here, and if you remember those two things, you will be able to solve any question of this type. This system, is it moving or is it in equilibrium? Yes. And when we say equilibrium, please remember there are two types of equilibriums. One is equilibrium of linear motion and one is equilibrium of rotational motion. You understand the two?
Yes, sir.
Is the fan moving? Is the fan running?
Yes.
But I don't find it running, it is there itself. It has not run away. It is? It is moving or not moving? But it is moving. Okay. So there are two types of motions. One is linear, one is, it is not having a linear motion, but it is having a, Now I change the words. That fan is in linear equilibrium. Linear equilibrium, not moving. It is not in rotational equilibrium because it is rotating. Understand? Why we say two type of equilibrium? But because in that case we are able to create two equations. And in physics, what do we want? More and more equations so that we can solve. Right. In this, which type of motion is there? No linear. And who is responsible for linear motion? Answer: force. Linear force is responsible. If there is acceleration in a line, then there has to be net force. If there is no acceleration in a line, how much is the net force? So in this system, if I calculate forces acting this side and this side, those will be equal. If I find the forces up and down, they should be equal. Understand? That will give me equations if I want to use. Understand? So this is the one way of creating equations. The other way, maybe there are so many unknown quantities that two equations are not sufficient. Then we jump to another thing. This system is not rotating also. If the system is not rotating, then why it is not rotating? Why it should rotate? It should have a torque, then only it will rotate. And if it is not rotating, how much is the total torque acting on it? Zero. Yes. That gives us the second set of equations. If I calculate total torque, then that sum should be 0, and that is the second equation. How it will be 0? Two ways. You write all the torques, make sum equal to 0, or you can say the torque clockwise are equal to torque anti-clockwise. That also you can do. It is one and the same thing. So these are the methods by which you get equations. How do you calculate torque? Force multiplied by the perpendicular distance from the point of rotation. We don't know where is point of rotation here. So we create it. Anywhere you find the point of rotation, the sum of moments about that will be 0. Because it's not rotating. All the points are not rotating. That means you have a freedom to choose any point as your origin. And here we do something. What? We choose, what is the formula for moment? Moment. Mass into distance. In the lever problem, you are doing mass into distance on this side is equal to mass into distance on this side. So that will happen anything which is not moving. You have seen the balance, no? If this is balanced, what is the condition? Mass into R1 is equal to mass into R2. That should be equal, or plus MR1 minus MR2 is equal to 0. Okay. Now you choose any point, the sum of moments will be 0. We have to do multiplications of force into distance. We choose such a point where a force is applied. Then we save one calculation, because from that point to origin is 0. So we save one calculation. It is only a trick of saving. Okay. Now let's move it. What is our problem? What do we want to find out? We want to find out friction acting here. We have to involve friction somewhere. The force of friction between ladder and the ground act along BC. Act along BC. This is direction of friction. Okay, is that clear to you? Horizontal equilibrium. That I told you, the forces on left side should be equal to the forces on right side. See this, in this system, which is the force acting in left direction, which is the force acting in right direction? Complete figure. N1 left.
Right.
Any other force? Left, right? No. So it is in equilibrium. System is in equilibrium. This gives us what equation? Yes, friction is equal to. You got one equation? And we write it. Friction is equal to N1. Okay? Is that clear to make a note of it? Because it's a very representative numerical and every student is supposed to know it. Like every student are supposed to know those two questions, river and umbrella. Same thing. It's not that this question is asked. It is the principles used in this question you can use in any numerical. And then you are master of it. There will be very few numerical which are out of these techniques. Okay, you got it. Now, is this system going up or down or it is in equilibrium? What do we call it? Vertical equilibrium. So for vertical equilibrium, please see here. The force is acting up, the force is acting down. N2 is acting up. W. Downward. You got it. Second is what? N2 is equal to W. This is another equation you got. Right. Two equations so far you have got. Not sufficient. We have not reached anywhere. Okay, let's go for more equations and we'll come to rotational motion. There is no rotation. We can take moment about any point and make it equal to 0. Which point should we choose? Yes, here we choose the point B. B. Okay, which are the forces working here? Actual forces which are working here. N1 is one force, N2 is the other, and W is. So we will have to calculate moment of three forces, right? Moment of three forces because three forces are acting here. Friction you cannot say because friction is reaction. It is not the force acting on it. Understand? When it starts sliding, friction will act. But which are the actual forces acting on it at present? Yeah. N1, actual, N2 and W. We have to find moment because of all these three. What is moment? Force multiplied by distance. How many calculations we have to do? 3. We have reduced it to 2. How we have reduced it to 2? By taking the origin here. How much is the distance of N2 from this point? 0. So that calculation is done. 0. What is the other calculation? W multiplied by this distance. Whatever is this distance. What is the other third moment? N1 multiplied by perpendicular distance. This is the perpendicular distance. Right? Now, use trigonometry. If this is 4 meter, can you find this? How much is that? That is 4 into sine 60. This is 60. 4 into sine 60. Okay. So you got N1 multiplied by this distance is the moment across B. Is this point clear to all? Because if you don't use that line, you would like to use this line. Here is N1 and this is the perpendicular distance. Perpendicular distance and that is N1. So how much will be the moment N1 into this distance, which is equal to AC. And AC is equal to 4 sine 60. How much is sine 60? Yes. So it will be 2 root 3. You got it? 2 root 3 into N1. How much is the moment of this? This multiplied by this distance. How much is this distance? Yeah, you all can calculate. Very easy. Not 2 meter. This is 4 meter. We want to find this distance.
2 cos 6 cos 2 cos 6 cos
2
cos 60.
Very good. Got it. 2 cos 60. Or you can go for 4 cos 60. That is total. Make half of it. That is 2 cos 60. How much it comes to? 1. Right? That is the distance. And how much is the force? W. So W into 1 gives the torque of W force. Now, tell me the directions. This torque, how it will rotate this? In clockwise or in anti-clockwise direction? Yes, this rotation. How much it is? How it is? Clockwise. Okay. N1 is working there. This is R. R and N1 working there. One is plus, one is minus. And it is not rotating. If it is not rotating, the sum is 0. That means both the torques are equal to each other. So that is what we get here. You have done it. W is given to us. That is 25 kg, 250 Newton. Okay, you do it and you will get it. Where is mu involved? Yes, N1 was equal to what? Friction. And friction is equal to mu into R. What is R? Yes, that is known to you. Do your calculation yourself and after that you match with this. So the result is matched. Don't copy it. Solve it yourself. And then see your solution and this solution should have the same result. Otherwise find out where you are mistaking. So in this question what you are supposed to remember is equilibrium. Linear equilibrium, rotational equilibrium, and that gives us 4 equations. And you can always find out 4 unknown quantities with that. Please see this question. A block of weight W rests on a horizontal plane with which the angle of friction is lambda. Okay. What does that mean? How much is the coefficient of friction? Mu is equal to tangent of angle of friction. Right. A force P inclined at an angle theta to the plane is applied to the plane until at one point it is moving. Find the value of theta for which the value of P will be minimum, will be at least. Okay. So in the limiting case, the contact force F is inclined at lambda to the normal. Only 3 forces act at the block. Have you studied Lemmy's theorem? Lemmy's theorem? No, that's why actually this is for JEE, IIT who have studied Lemmy's theorem. So I think we should not do it. Let's go to the next question. Yeah, this is a good question. Please see this. In the adjacent figure, mass of A, B and C are 1 kg, 3 kg and 2 kg respectively. Okay. Find acceleration of the system and tension in the string. This is again connected motion. We have done for connected motion earlier. In connected, how it is connected? How many strings are there? Strings. Okay. All these 3 are bound together and the length of the string cannot increase or decrease. Right? that means they are bound together. Whatever is the speed of this, the same will be speed of this and this, right? Because they are bound together. Understand? So it is the same case what we studied where three boxes were connected. These are same three boxes connected. Now, whether it will move on this side or on this side, it depends which force is larger. How can you get the force calculation done in this? The force along the inclined surface is equal to, we all know, it is F sine theta. Along the surface, F sine theta, normal to the surface, F cos theta. So there is a force working here. There is a force working here, and these are connected with one string. If the whichever force is larger, it will move towards that direction. That's all. So you can very well make it. Please do it. How will you find the force acting in this direction? mg sine theta, mg sine theta. Right? Here mg sine 30, mg sine 60. And see which is the larger. In one direction, mag sine 60, mbg sine 60. In the opposite direction, negative direction, mcg sine 30. Put the values. The answer should come to 21.17 Newton. You get the net force here, 21.7. Now because of this net force, the total system moves. And here see, when the system moves, how many boxes move? Answer, all three. So the net force has to move how many boxes? All three. Therefore, how much mass has to be taken? Sum of all the three. That is 6 kg. That is why when we count acceleration, we take the total mass 6 kg. Right? Then the students may confuse that there is an angle here. Because of these angles, will there be any effect on acceleration? Answer is no. We have to treat it like this, a straight line. This is a string. On one side there is one force, on other side there is a larger force, so the whole string will move. Pulley is changing the direction of motion, but it is not affecting the value of acceleration. Right? So for acceleration, it will be simple, force upon mass. That's all. And that is what we do it here. Make the equation. Free body diagram at A. Free body diagram at A. In your diagram, separate out A, only see the forces acting on A. We know the acceleration is A. That value is known to us. What is the force acting here? This is MA. Only its weight mag sine 60, and in this direction it is tension 1. I bring you back to the original. Yes, this here. If I separate it from the diagram, this one, this tension is T1. I call it T1, that tension. How much force is created by this? Mass into G. mg sine 60. mg sine 60 here, T1 here. As a result, it comes down with acceleration A, and that is what we put here. M1G sine 60 minus T. This is M1 into A. Only that local equation, not considering all the things. This is free body diagram. And it is very simple because you are making only for one body. Right. Because we are taking one body, we are taking force due to one body only. not because of all the forces. And with this you will find value of T1. If everything is known to you, you can always find T1. Is it clear? Done? Now we go for tension in the string between B and C. Here, B and C, this string. This is tension we have just calculated. This is second string. There are two strings in it. Two. One is this, one is this. No other string. So this tension you have just calculated T1. Let the tension in this string be T2. Everywhere it is same. It is not different at this point and this point, because the string is 1. Please see here. This string goes from this point to this point. At every point tension has to be same. And we take this tension as T2. Now this T2, we know the system is going here in this direction. We take this as free body diagram. Here, what is the force? T2. What is the force in this direction? That is mg sine 30. The result will be net force, and that net force is equal to mass into acceleration. Everything is known to us except T2, and here you get this equation. See, T2 minus mg sine 30. This is resultant is m into a. Here a is known to us, m is known to us, sine 30 is known to us, g is known to us. What you will get? T2. And you get it 17 Newton. Right? So do it and remember it. Okay, this is the next question. Block 1 kg placed over rough surface. Horizontal force F is applied on the block. Let us see what are the values of force of friction and acceleration of the block A if force F is gradually increased. If the block mass is 1 kg and mu s is 0.5, what will be the force of friction? Mu into r. Mu into, that is 0.5 into 1 into g, 10. How much it comes to? 5 Newton. So when we increase the force from 0 to 5, there will be no action on this block. How the force of friction will keep changing? Answer, it will be equal to the force applied. 0 to 5, it will be equal to the force applied. When we are applying force of 1, the friction is 1. When we are applying force of 2, it is 2. When it is 4, that is also 4. Up to 5, it is 5. That is maximum. Okay. And after that, what will happen? It will start moving. The moment it starts moving, then kinetic friction. How much is the kinetic friction? Mu into r again. How much is mu now? Yes. So how much is the friction now? 40? Yes, 4. Okay. So 4 is the friction. Right. So we need to apply how much force? Only 4 Newton. When it starts moving, how much force we are required to apply? 4 Newton. When we wanted to move it, how much we were applying? 5 Newton. So this is what we are supposed to reply. Understand?